Hi there, welcome to Rational Parent Functions. We're going to take a closer look at what happens when we start graphing these types of functions. We've simplified them, we've worked with them, we've solved them, but we've never taken a closer look at what they look like. So the rational parent function is just going to be 1 divided by x. It looks just like that. That is as simple as this type of equation gets. It has another name. Rational parent function is 1. The other one is called the reciprocal parent function. So here we're going to take a closer look at plugging in some values. So we're going to plug x into our parent function, and we're going to take a closer look at what values that function actually gives us. So if I try to plug in things like -5, well, 1 divided by -5, oh, okay. And that's all we're going to do for all of these is simply plug in for x. So whatever is down there is what we will plug in for. So the reciprocal of -5 is 1 over -5. The ones I really wanted to take a closer look at is the fraction. When we do 1 divided by -1/2. So keep, change, and flip is where we're getting that -2 from. I would plug into the other side. So 1 divided by 1 over 2 is just 2. 1 divided by 1 is 1. What happens when I try to plug in something like 0? Because I would have 1 divided by 0. And we've talked about that before because that one does not exist. That's what DNE stands for. You'll see that a little bit in upper level math, but I want to start introducing you to that term now. Does not exist. It does not happen. So if I try to plot all of these points on, so it kind of looks something a little bit like this. There's these kind of curvature doing here, and it looks like I've got these two pieces, and they're getting close to the x-axis and they're getting close to the y-axis, and we have some new words to describe that. Here is what it will look like, your two pieces all together. So the term asymptote is what is going to come into play. Think of it like a boundary. So here I'm going to put our vertical asymptotes in blue. So that's this one right here, right down the middle. You can see it kind of gets close to the y-axis, but it never quite goes through it. So this vertical asymptote is at x equals 0. It is a line, so be sure you write it as an equation. And you'll also see we have something kind of going on horizontally right here at y equals 0. So there's our horizontal asymptote. Think of them like boundaries, like guidelines, if you will. So that's kind of what we'll take a look at. Hence my Lord of the Ring theme, you shall not pass. So these are going to be how we're going to actually graph these. We're going to use these asymptotes to guide us. If I take a closer look at the domain, so again, that is all of the x values, all of the input, all these negative x's, and I can see that in my table. And then I've got all these positive x's, so it looks like I'm pretty good to go, except for 0. So that is where I'm going to have to completely skip over that number. So all the real numbers except for 0. Range, bottom to top. What are all the values the function gives me? Well, I've got negative y values. I've got positive y values. I just don't ever get to 0. I get close to 0 with those boundaries, but I never quite get to it. So just be sure for your y values, you skip over 0. What happens if I try to find the y-intercept? Now, the y-intercept, you'll notice, doesn't actually exist. I don't ever cross that y-axis. I don't ever intercept the y-axis. If it helps, you can see I wrote the coordinate because normally the y-intercepts are 0 and a number. Where did it cross the y's? Well, I tried to plug in 0 and remember, it didn't exist. So that's kind of where that one comes from. Now, the x-intercept is really interesting because that's the other way around. The x has the number, and I'm looking where y is equal to 0. So if I do a little plugging in, I try to solve for the x-intercept. I multiply both sides by x, but I'm pretty sure that x times 0 is still a 0. And I'm pretty sure that 0 does not equal 1. So that's why we don't have an x-intercept. You can see it in the graph, but you can also see it algebraically. Here is our rational parent function. You can see that I'm kind of starting it out. This was the basic one. So now let's take a look at what happens when we play with the a value, the one on top of the fraction. Oh, so as a is getting larger, I can see the graph is getting pulled. It's getting stretched out. So it's going further and further away. If it becomes a fraction, it's getting compressed. It's getting squished towards those axes. And then when it's negative, see how it flips to the other side. So I've got, here's the original stretch, compress, and when it's negative, it flips. So there's the a value. H, okay, let's see what happens when it becomes positive. Okay, it's shifting the graph here. Notice how h is 5, and look at where your vertical asymptote is. It's right here at 5. So you can start to see how changing the h will change the vertical asymptote. And I can kind of see that right here. -4. Well, if I try to plug in a -4 here, I can see it went left. That's kind of how all of those are going to work. Let's try a k value. Well, if I try to shift this, it's going to go up, 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 up. And when k is negative, it drops it down. Here's the good news. If I try to shift it, let's say up by 2, now I can see where my horizontal asymptote is. You can see those boundary lines. So that is, again, how we are going to graph these things. So the a value is going to be your stretch and your compression. Negative will cause that flip. You have your h values and you have your k values. But luckily, those rules are the same thing. It looks like we have a few transformations. I see this on the bottom, and I see a +3 on the top. Well, there's still a 1, and that kind of matches our parent function. So it looks like I'm just going to shift this right 2 and up 3. So from our parent functions, we're going to do a little bit of shifting. So I'm going to shift this right by 2, and then I get to shift the graph up by 3. There's no flips at all. So here's where my final graph is going to be located. And you can see those asymptotes have moved. So my vertical happens to be at x equals 2. You've got the horizontal asymptote is at y equals 3. Domain, okay, looks like I have all the x's I could possibly have. Except that boundary right there at 2. X is equal to 2. I can't have that. Again, try plugging in. What happens when we plug in for 2? Dividing by 0. That's why that's there. Same thing on the range. I have all these negative y values except at 3. I need to skip over that. Well, this is interesting. This one actually has a y-intercept right here. I just need, it's kind of hard, it's not exact, so let's try to solve for it. So again, y-intercepts have a coordinate at 0, a number, y. So all we're going to do is plug this in to our equation. And now we can solve and actually find where that y-intercept is. So you can see where graphing may not always be as helpful. And I listed 3 different values. So you could list it as 2.5, you could list it as 2.5, or you could list it as 5/2, but somehow being able to identify that y-intercept. X-intercept, again, I can see it does cross the x-axis right here. It's not exact, so I need to do a little bit of solving again. X-intercepts have x has the number 0 for y. So this one is going to take a little bit more solving because I'm solving for x. All right, so maybe we should move this 3 over. So I'm going to subtract 3, and I'm going to rewrite it as a fraction because now I can use my cross multiplication solving shortcut. I'm going to go ahead and distribute that -3. And finally, I do get an x-intercept at 5/3. Something to keep in mind. Why did this example have intercepts? The parent function did it. What makes this one so different? Well, take a closer look. This one shifted. It moved right 2, And instead, what I love about this is normally this was the boundary. Our y-axis was the boundary. But since it got shifted, I now have access to that y-axis. I can cross that. There's not a restriction. There's no boundary there. And real similar, I shifted the graph up. Normally, this was my boundary. But now that I've shifted it up, the graph has crossed that x-axis. So these transformations are allowing us to cross both the x-axis and the y-axis. So let's take a closer look at this one. So I see a 1 has been shifted to a 2. I see the x was by itself, and now it's a -2. I see the -2 is now a +4. Well, if it went from 1 to 2, that looks like that was multiplied by 2. So I have a vertical stretch of 2. So everything got multiplied by 2. Originally, I wasn't shifted anywhere. I went from x to x -2. So here I've gone right by 2, so right 2. And the last one, I'm starting all the way at -2, and I'm going up, you could say, to 4, because I've added 6. So I've gone up 6. If you're curious, here's what it actually looks like. You can see where graphing rationals is going to get a little crazy, and there might be a little challenging to see. So here's the horizontal asymptote from -2 up to 4, so I can see that. Here's the original stuck at 0, and you can see it's gone to the right by 2. I love those guidelines. They really make these graphs helpful. I love a good outline. Who'd have thought we'd need outlines in math like we do in other classes? All right, this is the last one that we're going to graph, and I threw a couple of extra things at you. So not only am I shifting things left and right, I also have a negative on the top, which is going to flip our graph across the x-axis. We're going to go left by 2. Again, if you need to rewrite it, it might be helpful. Normally, our graphs have a minus sign. This one doesn't, so I always like to rewrite it to help me see it. And I've gone down 4 because it's a -4. I'm subtracting 4 from all these values. That's what's shifting it down. So I went left by 2. So I'm going to have here at -2. And then I went ahead and went down 4. And instead of putting these graphs in this quadrant and in this quadrant, it's been flipped. There's that negative that's on the outside. So be real careful when you graph it, because you need to flip them to get to something that looks a little bit like this. All right, vertical asymptote is here at x equals -2 in blue. The horizontal is at y equals -4. Your domain, basically everything except -2. Watch for your boundaries. Same thing on the range. Everything except -4. All right, creating a rational function. Here our goal is to have a domain of, okay, -infinity looks like I'm trying to skip over 6. So I'm going to write that as a note. And then I would need to have a range and all the way over 4 past. So y cannot be 4. So if I can have everything except 6, basically I can't plug in 6, and somehow, so I'm going to leave a little skeleton, I cannot equal 6. Well, hopefully that means I've shifted the graph right by 6. Because again, if I try to plug in 6 here, can't divide by 0. So I've gone right 6. The y values look like I just can't go to 4. So looks like I just need to shift the graph up 4. Now, as far as what could go in the top, this is where you can get creative. If you'd like, you could leave it as a 1. That graph would have that domain and range. You could put a 4 up here if you want. Make it stretch. Here's the fun part. You can even make that negative on the top. It's really going to stretch it, and it's going to flip those quadrants, but it won't change the domain and the range. So you could have a lot of different answers for that one. Using what we know about our transformations, decide or identify which functions below would cross the x-axis, the y-axis, both or neither. So on this first one, I can see I have a negative and I have a 2 and I even have a +5. So this one is going to shift the graph up by 5. Well, if I shift it up, that's going to change the horizontal asymptote, which will allow us to cross the x-axis. So this one would have an x-intercept. On the next one, okay, I'm not really shifting the graph up or down. Looks like I'm just shifting things left and right. So I'm moving the vertical asymptote, which will let me cross the y-axis and give me a y-intercept. I'm not shifting things left or right. I'm not going up or down. I'm just going to make the graph very wide and I'm going to stretch things out. So because I'm not moving up or down, I'm not going to have access to the x or the y axis. I'm not shifting things over. So this one is neither. It won't cross. It'll look just like the parent function, just kind of stretched out a bit. And the very, very last one, okay, I see a -3. I see a +1. So this one is shifting right and up 1. So I am not only changing the vertical, I'm also changing the horizontal. Both of them are getting shifted. And if you want, here's a quick sketch. You don't have to sketch. I just wanted you to visually get a chance to see what I was talking about. All right, we'll do some extra practice in class, so stay tuned.